let's start and welcome our presenter for today's ITLS Leadership and Policy Seminar Series. Before I do that, though, I would like to acknowledge the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I'm currently on the land of the Gadigal people of the Eora Nation. Pay my respects to the elders of past and emerging, and further acknowledge the traditional owners of the country on which you are, and pay respects to the elders past, present, and future. For the guys who are joining us remotely, please keep yourself muted. So we will have a Q&A section at the end of the seminar, about like 20 minutes, at which point I will invite you to unmute yourself and ask a question. Should also say that the recording of the presentation will be available post the event, as will any slides that our presenter has had to make available. So it gives me great pleasure to introduce today's presenter, Professor Kai Hoberg. Kai is Professor in Supply Chain and Operations Strategy and Head of the Operations and Technology Department at Kühne Logistics University in Hamburg. He has been a visiting researcher at leading universities such as Cornell University and NUS Business School, SET Business School, Oxford, and of course the University of Sydney. So he has been with us some time ago, not twice, and so a lot of people in the room will actually know Kai already. But it's great to have him back. Before returning to academia, Kai worked as a strategy consultant and project manager in the operations team of Bruce & Company Strategy. His current research focuses on supply chain analytics and the role of technology in supply chain management and supply chain strategy. His research is working with partners like McKinsey Company, Fire, Procter & Gamble, and the World Bank, and some colleagues in the room. And so that's some good outputs, including recently a book and wonderful things. And so it's great to have Kai back with us. And today he will talk about the fascinating topic, which is human-machine interaction in demand forecasting. And so without any further ado, Kai, the floor is yours, and thanks for coming and presenting to us here. Thanks.
Thank you, Rico. Well, welcome to my session. Thanks for spending lunchtime with me. So I want to talk about a topic that has really fascinated me for a number of years. So we all know AI is getting better, but there's still a human in the loop. And I've been working in different research projects on this topic. So many of them with big companies like Bayer, like Infineon, and a partner company that I need to keep confidential. And that's actually the company that triggered this research over here. So the paper was recently accepted at EJOR, and I will provide you with a QR code at the end. And I can certainly also provide the paper right away. So it's a joint work with my PhD student, Natme, and a former PhD student, Christina. She's now assistant professor at the Technical University of Eindhoven. Good, so let's start with some motivation. See, sticker doesn't work anymore. Let's use this one. Also doesn't work. Now we go. So, all right. So I picked a very Australian example, I think, Tim Tam. And you realize one important element there is forecasting the demand for this product for tomorrow, for the day after, for next week. And you realize, yes, that's an important aspect, right? Because you need to forecast the demand in order to replenish on time. And so the company we've been working with is really creating wonderful forecasts. They are using advanced AI technology to create these forecasts. And to put this a little bit into context, we realize, yes, one of their clients, a big UK-based retailer, and they have like 20,000 different articles in an average store. They have around 500 stores, and they also need to forecast demand for the next 21 days in advance in order to really ensure that they can replenish on time. And if you do the math, you realize, yes, that's a lot of decisions. That's a lot of forecasts that are generated. So if you do the math, that's 20,000 articles per store, 500 stores, 21 days, that's 210 million forecasts that are generated and updated every day. And how can you do that? You realize, yes, probably you have two options. You have the human and you have the machine, the AI system. And you realize, yes, human is probably not really the best way to generate this huge number of forecasts. So if you look at the issues there, you realize, yes, humans have a lot of limitations. So there is limited rationality in their decisions. They have mood, they have biases, and it's a lot of effort to create a forecast. AI certainly has some strengths, but has other limitations. So, for example, the data availability, is the data quality all right? What is the context? Does the AI understand the context? So ultimately, we realize we need both aspects. We need the human and the AI. And the overarching question is here, how should they be working together? How do you best bring the expertise and the strengths of the human and the AI on board? And this is really what our paper is trying to do. We want to provide some managerial implication and some insights on how humans and AI can best work together and how to best use the human knowledge that is there in AI forecasting. So if you look at the positioning of our research, well, there are two aspects. The first aspect is really generating wonderful forecasts with an AI system. And that's what our partner company does. So leading analytics provider in Europe, all the major European retailers are clients of, many of them are clients of that company. And they have really some advanced systems to generate the AI forecast. So that's probably there. And however, there is still human. So if I think about this British retailer has roughly 200 planners. And these planners get the AI generated forecast and can decide, well, let's keep this forecast or let's override this forecast. Let's update this forecast based on my best knowledge. And for example, this is important because there is not enough information to the system, for example, for competitors' action. Maybe there are promotions that are not really planned well. There are new products that have not a lot of history, a lot of data in the history, and that's why human could do better. So, and this is really the forecast of our research to understand two things. First thing is, when do these planners feel that they need to adjust the AI generated forecast? When do they feel they do know better than the AI system? And the second question is, if they override, do they really improve? Do they really create a better forecast compared to what the AI had done? And well, you can stylize this problem in many contexts outside forecasting, right? So you can think about many planning decisions where an AI system or some advanced algorithm provides an initial solution, and a planner can decide to override and enhance, or hopefully enhance, this initial solution. So that's really what we wanted to understand. When do they adjust the forecast, and do they really improve based on their adjustment? Cool. So if we look at literature, there's a term for that, and Ben knows this judgmental forecasting stream rather well because he did a nice overview paper. But if you look at judgmental forecasting, so humans that override certain forecasts, you realize the impacts are actually mixed. So there's some literature indicating that upward adjustments are typically driven by optimism, and they are maybe not as valuable as downward adjustments. So people who are more careful and reducing a forecast have a better chance of improving this forecast compared to people who are rather optimistic and increase the forecast. And this is actually also happening in a lot of other contexts, so outside pure forecast. So if you look at the reasons, yes, there are certainly many behavioral factors, behavioral biases that could play a role. So, and there's a lot of literature on these bias, random judgment, anchoring bias, over and under reactions. And I guess it makes all a lot of sense. So this is typically done in a rather generic context. So think about lab experiments that really provide a generic product, and a decision maker should make a choice. However, the product might also play a role there. And there's a little bit of literature here also on the product-related drivers. So to really understand what is the impact of the product margin, what is the impact of certain promotions, and what are maybe substitution rates affecting there. But in general, this is really not so much the focus of the literature. Cool. So if you look at what we find as our contribution to the previous research, there are 3 things. So first of all, we work with a huge data set from the real world, and we are getting a lot of data on different products and product characteristics and how planners are affected by these product characteristics. So we can really evaluate these different factors and understand, yes, what is the price having a role? What is the freshness of a product having a role? What is the discount offered playing a role in the decision process of the planner? Then we started the setting with a massive number of forecasts. So there are too many forecasts to really work on. So we limit our data set to some 30 million data points. But you can imagine, yes, a massive data set. And if we look at prior research, yes, they might have 10,000 decisions. So certainly also requires new approaches, and I come to that. And then finally, we also need to understand the efficiency of these adjustments. And these AI systems are already using a lot of important features. So like the weather, like discounts, like a lot of other information that may or may not be available to normal systems in prior research. So if I look at that, yes, what's new? So as first would say, we really address that using a massive number of forecasts that are generated by AI systems and machine learning systems. And we also use machine learning to really analyze that. So I think that's a nice context. So the forecasts are generated using AI, and we are using machine learning and AI to really try to make sense out of that. Cool. So that's really the background. So let's talk about the research setting. So we have this AI provider, and we have one of their clients, this British retailer. And this AI provider provides, well, a huge amount of demand forecasts every day, so 10 million. And they use a lot of features, so 100+ different features that they feel are important and feed into their models. And these forecasts are generated up to 21 days ahead and are updated over time. So if there is a forecast for the sale of an item for, I don't know, March 17th, the first forecast is generated 21 days ahead. And then each day the forecast is updated based on the data and information provided to the system. So, and then this is given to the retailer. And the retail, yes, he has more than 500 stores, roughly 20,000 articles on average per store, 20,000, 200 planners roughly. And a lot of what they do is they adjust these forecasts and override them. One challenge they are seeing there is there's no feedback mechanism. So when we started this research, there was no feedback to the planner. Was this override good or bad? So they do how they feel it would make sense, but they don't get any feedback. So one common challenge, for example, is let's assume that there was, and that's a real world example, for certain products, the forecast was too low last year before Christmas. And the planners realized, okay, the AI generated forecast was too low last year before Christmas. So what they would do is now, well, last year, the forecast was too low. Let's adjust the forecast and make it higher. What they forget is, well, the AI-based system learned that the forecast last year was too low. So it already adjusted the forecast upwards. Now they overcompensate and make the forecast even higher. So, but there's limited explainability. Actually, there is almost no explanation of the numbers that are provided, and there's no feedback. And that was the status quo until we published the paper. They are now working on some advances based on also our contribution here. Cool. And one important element is, yes, at some point, the planner might adjust the forecast. So, for example, a human would say, this AI-generated forecast, I increase it by 20%. So, but there's still the forecast evolution. And what the system then does is it will also update the human-adjusted forecast over time, considering this 20% surplus that the planner wanted to provide. And then ultimately, at time t, we're going to have the real demand, 15. And that's a point where we need to evaluate who was better. Was the human better, the human-adjusted forecast better, or the original AI forecast? So in this case, it seems that the original AI forecast is closer to the actual demand than the updated, overridden forecast by the human. Good. So if you look at the data, yes, a huge data set. We limited to 10 stores. We filtered out a massive data set. We were still left with 30 million data points. And if you look at that, roughly 5% of these forecasts have been adjusted by humans. So 5%, that means in 95% of the cases, the planners are okay with the forecast that is generated by AI. But for 5%, they feel we know better. So we did some feature engineering to really create a better understanding of what are potential drivers, what are potential explanations of these human adjustments. And we come up with a long list of variables. Some of them are product related. So what is the price of the product? Is it a fresh product, not so fresh product? Is there a discount at the moment? We looked at some store characteristics. So where is the store? What is the overall sales of the store? Maybe something has to do with the date. Something might have to do with holidays, public holidays or school holidays. Maybe something that has to do with the weather. So we try to identify what are days with particular good weather compared to the average weather in that month, or bad weather with bad weather in that month. And how was the adjustment? So was it a positive adjustment or a negative adjustment? And what is the magnitude of the adjustment? Is it a small one or a bigger one? So, and many more features. And then we look at essentially two dependent variables that are binary, either 0 or 1. So first one is it an adjustment? So was this adjusted, yes or no? So 95% were not adjusted, 5% were adjusted. And then if it was adjusted, was it adding value? Was it bringing the final forecast closer to the actual demand on that day for that product, or did it not add value and the original AI forecast was better? So that's really the setup. So, and if you look at some descriptors, you realize, yes, on average, roughly 5% of the forecasts are adjusted. If you look at the adjustments by product category, you first realize, yes, fresh products receive more attention compared to non-fresh products. And then if you look at the different product categories, yes, you realize for some products, like garden or meat, fruit and vegetables, this is actually higher. This can go up to 20%. If you look at other products, there are pet-related, barely any adjustments. So obviously, planners have different priorities and want to really put a different focus on different product categories. Good. So now let's dive into the analysis. So you realize, yes, there are many possible ways to address it. We decided to really use machine learning models because also based on the data set, based on the number of potential variables, this is something that could make sense, and it did make sense. So we essentially looked at decision trees and random forests. And we structured the research into two phases. So in the first phase, we again focus on the when do they adjust. In the second phase, do they add value? And the dependent variable in phase one was the adjusted variable. In the second phase, it's the valuable variable. And if you look at the sample, yes, for the first phase, we can use all the 30 million data points. Later on, we can only use the 5% of the 30 million that have been adjusted, because there we know are they valuable or not. So that leaves us with roughly 1.5 million data points. And what was interesting there, it seems as if you can throw a coin. 50% add value, roughly 50% add value, roughly 50% don't add value. And when our partners saw that, they said, well, that's great. Now we have really a reason to take out the planners. They are messing with the system anyhow, let's just take them out. But life is a bit more complicated, as I will show in a minute. So, and for each phase, we had two analysis steps. And the first stage, we identify drivers. What are really factors that are relevant? And then the second step is, how do they come together? How can we predict if there is an adjustment or a valuable adjustment or not? Maybe I stop here for 1 second and leave room for questions. Any common question on our background here?
How did you deal with that if anybody, human and machine, over forecast, you obviously have additional revenue. You can quantify that. But if you under forecast, then you're out of stock and you don't know how much potential revenue you lost.
That's a critical question. So if there is no inventory or if there's not enough inventory, certainly we're gonna observe not so high sales, right? Either zero sales if there's no inventory, or fewer sales than demand. And on average, that company had a service level of some 98%, which is very high, but we couldn't quantify if there was no inventory or not. So that's a limitation we have to consider. So, and that's a fair point. That's maybe you were one of the reviewers. That was also a question one of the reviewers asked us. Any more questions or comments? Good. So I hope this is rather clear. So if I look at that now, let's first focus on the adjustments. We try to understand, when do the planners feel they know better? When do they feel we need to intervene and we need to override the forecast that was provided by the system? And you realize, yes, we did analyze the drivers, and we just looked at the importance of different drivers. And there you realize, yes, and that's rather intuitive, right? Price seems to be the most important feature. So I come to the direction of that, and that's also as expected. Second important feature is it a fresh product or not fresh product? Then month is an important feature. In certain months, there are more adjustments. In other months, there are less adjustments. But since we only have data for 1 year, we couldn't really identify patterns there. Then the sales quantity, how many units are sold? Are there few units sold or more units sold? And maybe last one, price type. Is it a regular item with a regular price, or is it discounted? So now let's try to understand a little bit what's going on. Let's look at the price. So we classified the price into in a histogram between items that are worth with a price of less than £0.5 to items that have a price of more than £5. And you realize, yes, most of the items, so the bar chart indicates, yes, most of the items have medium to low price, but there are a certain number of items with a high price. So if you look at the characteristics of the percent adjustments, you realize, yes, items with a lower price, they receive less adjustments, and then the number of adjustments grows as the price increases. And that seems to make intuitive sense. So they really focus on items that are more expensive and spend more effort to really think about the forecast for more expensive items. And this is also maybe not too surprising. If you look at product freshness, so roughly half of the products were considered fresh with a shelf life under 14 days. Others are non-fresh, and they spend more effort on the fresh items. For items that have reduced price, if there's a promotion, and for items if there is a period of particular high temperature. And that was kind of surprising for us, the temperature part, because the company was already incorporating these temperature forecast, weather forecast into their AI planning system. So they would already increase the forecast for, I don't know, barbecue meat on weekends if there is particular good weather in the UK. So, but planners will still get involved more frequently. And that brings us to the second part. How do these effects add up? How do these different features play together? And there, I think that's a simple decision tree, right? So with a few nodes. So for example, if you realize, yes, it's a product that is not fresh and the price is normal, that would really trigger only on average 3.3% adjustments. So for items with normal price that are not fresh, few adjustments. If you look at items that are fresh and have a high price, here you realize, oh, that's already 10% of adjustments. So they spend 3 times more effort on these items compared to that items. I think that's something important to know. Yes, we understand when do they focus on really improving the forecast accuracy. So that's the first part. Now, the second, probably more important part, do they add value or not? And here, again, the very similar approach. So what are important features? And the first very important feature is the direction. That's really the most important feature. Then the sales quantity, price, freshness, and was it a large magnitude adjustment? Was it adjusting the forecast by more than 50%? Cool. And you can also realize, yes, this is becoming a bit more complex. So again, bringing these two effects together. But you realize, yes, for some of these adjustments, planners really don't add too much value. Only roughly in 1/3 of the cases they add value if the magnitude is not so big and it's a negative adjustment, and if that is a fast-selling item. So rather low chance of adding value. In other cases, this is different. So they have more than twice the probability of adding value. So here they add value in 69% of the cases if I go down this decision tree. And you realize, yes, this is a rather small number. So that's roughly 7 or 8% of the forecast. But this is really providing much higher value there. So, and that we had some very, very good discussions with our research partner, and they realized, if we had known that, we could provide the planners feedback before they execute. We could tell them, look, if you do this type of adjustment as you are planning to do, you only have a 33% chance of really improving the situation. Do you really want to do that? Are you sure? Or 69%. Okay, if you do as you plan, there's a good probability that you really improve the AI generated forecast. And this is something they are now on the way to really implement in the system, to really give the planners first feedback before they can execute, and afterwards also give them feedback afterwards. Because, and that was for me very surprising, that didn't exist. It's very important, right, to give the planners feedback on their decisions. So if you look here at a very simplified analysis, when do the planners add value? Well, they add value if they do positive small adjustments. They don't add too much value if they do large positive adjustments. And that's really also in line with research. So planners might be rather optimistic. They do a large positive adjustment, so they really increase the demand forecast, but ultimately there's only less than 40% chance that this is paying out. And you realize, yes, these numbers are all rather close to the 50%. So that's something where the AI provider said, well, look, we are typically having a rather good system. So it's really like flipping a coin. There are only few cases where our system is not too good. So yes, up to 66% here, potential of positive adjustments. Cool. So let me discuss and conclude. So first of all, it's still all the retailers I've been talking to, they don't want to automate. They don't want to have a fully automated system. They want to still give planners the opportunity to intervene. And so this is necessary to understand. Yes, planners will be there in the foreseeable futures in many companies, maybe excluding Amazon, but that's a different story. At the point of the decision. We wanted to understand when the adjustment is likely to happen and if it adds value. We used some machine learning tools to do that. And we find that there are drivers and we can quantify their individual effect. And we can bring these different drivers together and quantify the collective effect. And what was maybe not too surprising, but we found evidence is that the variables that are already considered by the AI system, like the weather or discounts, are not really strong determinants of value. So yes, there is potentially some double accounting if the AI accounts for good weather, and if the planner then feels, yes, there is good weather, let's further increase the demand forecast for these products. Managerial implications. Yes, we will also, one thing that we consider is, can we feed the adjustment as one additional feature to the AI system, and then see when should the AI system really consider this or not? And that's really ultimately taking the decision away from the planner, but that could be one way forward to really think about that. Certainly the retailer can train the planners to make better adjustments. So I was still very surprised that there was no really good training and no feedback loop in place before, and this is now being implemented. So it also triggers some future research. So in particular, what is explainability? Is explainability important? I feel it's very important, because if a planner only sees the forecast 45 or 12, how does he know that this is really something valid? So we need to give planners the opportunity to understand, yes, it's 45 because there's a promotion and it's a Saturday, and this is really twice the demand that we would normally observe during a weekday without a promotion. So that type of understanding. Then blending the AI focus with human adjustments, I talked about that. And maybe finally an efficient feedback loop. So, and we probably need to understand, yes, maybe feedback is not required all the time because this will slow down the planner, but when to really provide the planner with information that's important. So I think that should bother all of us, because ultimately this will also affect the way we do planning and supply chain, not only forecasting, but everywhere. So if you look at current planning system, like our forecasting system is, here the objective of the planner is really to improve the performance at the moment of truth. So the planner spent a lot of time looking at AI generated forecast and then trying to make a decision. Do I want to adjust? How should I adjust? And that's at the moment of truth. In the future, and at some companies like Amazon, that's already happening, planners should really spend as little time as possible making these adjustments. She or he should rather really try to improve the data, make sure that more data is available to the AI system, that the mechanisms are better, that the systems are better, and that really will also reduce the workload of the planner for this, what we call output adjustment. So he or she spends time on the input, and based on that, this planning accuracy that was an important KPI before will be also getting other KPIs, like what is the data quality? How often are alerts generated that need to be manually reviewed by the planners? And how much exception handling is really required there? So I guess that's something that will certainly advance over time, but this decision at the moment of truth will probably be going away. Cool. So that's really what I wanted to tell you this lunchtime. So here's the paper. So I can also share the paper with Rico and provide the paper that has been published in December in eJournal. And here are my contact details. Thank you.
We have a now which is a session. We'll open the floor to questions, and we usually start with someone face-to-face audience, and then quite the online community as well. But are there any questions in the room?
Yeah.
Please.
So thanks, Brad. Very interesting. One of the dependent variables is where the value was added. I wonder if there was some further analysis on something you did on the sort of magnitude of the value that was added. I might sort of loop back into the question earlier, which was getting at sort of underage versus underage costs. So yeah, because adds value or not, but by how much is perhaps a way that might make the analysis more involved, but it'd be interesting to see how much it makes a difference.
I'm not sure we looked too much into that, to be honest. So, well, first of all, we realized, yes, magnitude is important. Direction is a little bit less important. And if I think about this stockout situation, I'm not really sure to what extent we are able to analyze it, because we have a lot of data available in the system, but what we didn't really have is the inventory information at the point in time, because it was not available to us. So we couldn't really, and even if there was inventory information, we know that that might be very inaccurate, right? So I think that would require a little bit more effort there.
Would you say that potentially there's a bit of a overestimation of the impact of the adjustments? Because if something is out of stock, then certain substitution purchases happen, which are to some extent cushion the lost revenue. For example, okay, if there's no Diet Coke, then maybe people buy Coke. Zero, yes.
Yeah. I think there are two elements, and you raise again an important point there. The first point is, yes, if there was an adjustment, and that means that, let's take a slow-moving item, average sales of 0.6 per day. Yes, is it really important? If there's an inventory of 10 items and forecast might be 0.6 or 0.8, actual demand is 0.12. But when is a replenishment triggered? So the replenishment is triggered maybe only if there are 2 items left on shelf. So if there are 10 items left on shelf, it doesn't really matter too much if I can improve the forecast from 0.6 to 0.8. So I think that's actually the 2 points together I wanted to make. Yeah.
Let's involve the remote community now, please. Are there any questions from you guys who are joining us remotely? And if so, let's unmute yourself and ask a question.
This is Arun here. Hi, Professor Rico, how are you? I just had one question. So I have planning team. We work closely with our planning team. So when it comes to adjustment, we also look into the transport component to understand the value of our adjustment. So pre-COVID levels, days, or during COVID days, the sea freight was the transportation cost was very high, and now the transportation cost has come low. So before, we were manually adjusting to fill up the whole container so that we reduce the transportation cost. And now we are more focused on getting LCL, less than container load. So we are going more accurate to the projections which are coming. Did you come across similar issue while you were doing the whole study? Was it part of when you defined value, does the transport cost also comes under that term value of forecasting? Is it there? That's the only doubt.
So 2 answers. First, our data was, we actually decided to go for pre-COVID data. So we took data from 2019 because we realized 2020 things would go wild, and we wanted to ensure that we have a more steady picture of the data. regarding the quality, how to quantify if it's valuable or not, we just took this very simple approach and said, we compare the actual demand on a day for a SKU in the store with the forecasted value, and then see, are we closer with an adjustment to this actual value, or is the original AI forecast better? So everything else comes afterwards, like the replenishment strategy and the lot sizing and stuff like that. So we wanted to leave that out, although we realized what many planners would do is, instead of increasing the reorder point, they would just increase the forecast, and based on that, they can achieve the same, right? They can trigger orders earlier and ensure that there's more stuff on the shelf. But that's what, in my opinion, shouldn't happen. So if you want to adjust your safety stock level, adjust the reorder point. Don't adjust the forecast, because there are two different instruments. I hope that answers your question.
Yes, it does. Thank you.
This is, oh, sorry. That's exactly one thing that I wanted to refer to, because apparently there is a big difference between forecasting and planning in general. Forecasters and planners are two different groups of people in supply chains. So when you talk about forecasters, they're most of the time outside supply chains, sitting and looking at the market and without looking at what's happening within the supply chain. The planner is the one who looks at what's available, what's the inventory level, who are we dealing with, the suppliers, the restrictions of transport, the logistics side. So these are very different people. So when you refer to
this organization, no.
Yeah, that's right. So you actually use the terms interchangeably.
Yes.
So I feel that when you talk about replenishment and forecasting, you're basically talking about planning all the time. So
yes,
you're not talking about forecasters. Because forecasters, in what you talk about Amazon is completely automated in terms of forecasting,
yes,
but not in terms of planning.
Yeah.
A lot of planning is actually manual, because they can manually adjust forecast based on the requirements, internal requirements of Amazon. So because Amazon does have a lot of internal issues rather than external dealing with people outside. So I guess there is a big difference here. And basically what you're referring to here is actually planning, it's not forecasting.
So in that organization, the planner is also responsible for the forecasting. So it's an integrated role, and I know in many organizations that's different. And that's when, well, if you have different people, then, well, you can certainly take these two processes better apart, right? The forecasting compared to the planning. But here in this organization, it's very integrated.
So in AI machine that you use, it's also basically considering the internal factors. So basically the replenishment restrictions and anything related to suppliers, supply availability, all the risks of supply, they're all integrated into the AI.
So that's for the forecasting. Forecasting is taking a lot of information and features into account. And then this forecast is just fed into the planning system for the replenishment. And there, all these different constraints like lot sizes, delivery schedules, supplier lead times are considered.
Did the quality of the planner intervention improve depending on the time horizon? So you're mainly looking at intervention today, what did it look like in 21 days? But I guess there were also interventions that said actually the forecast in 5 days or in 4 days is going to be this and not what, or was it a similar?
We didn't look into that. We only compared the final forecast for a day with the actual forecast, with the actual demand.
So the forecast for 21 days out then?
Let me go back to this page here. Yeah, so there was an intervention, and maybe the intervention was, I don't know, 16 days beforehand, or the intervention was later and only 5 days beforehand. For us, that wasn't making a difference. We only looked at the final forecast and the actual demand. But it's an important point, and I really would like to understand that. are forecasts that are adjusted a few days before better than forecasts that are adjusted earlier?
Because they might be worse as well. I mean, you know, intuitively you would think 2 days in advance, I have a better idea of what's going to happen, but it may actually be even worse, the level of intervention.
Yeah. And ultimately, if it's only done 2 days ahead, maybe it doesn't have any influence because you can't change your replenishment anyhow. But that's a different challenge.
Just a short question. Was this 50% correctness rate actually consistent over time, or did you see that as AI improved, that this correctness rate and adjustment also decreased?
So there was some fluctuation, but there was no general trend. So, and for me, that's clear because there was no feedback provided, right? If there was no feedback, how can you learn? It would be interesting to now come back once as they are now being trained and getting feedback, if they are really able to improve. And first of all, are they reducing the number of interventions, 5%? Are they getting lower? And then do they really spend more value than before?
How did the retailer feel about this? So if I had a bunch of buyers, which is, you know, I used to run a few bunches of buyers.
Yeah.
I'd be pretty happy with those stats. They're only intervening 5% of the time, and half the time they get it right.
Yeah.
Because you want your planners to have a go in the market to try things. So how did the retailer feel as opposed to the AI?
For the retailer, that was rather surprising.
Right.
So they were feeling that they are adding value much more frequently than 50%. So for them, there was really something where one question they asked was, should we change the process?
Right.
Should we really maybe take away some responsibility and some opportunities out of the jobs of the planners? And maybe the planners can work on other stuff, or they might also reduce the number of planners. So they were really assuming that they were adding value much more frequently.
The bad news I've got for your supplier, for your partner, is that a lot of these adaptive forecasting support systems that are currently in the market, and we're applying one of them for Woolworth in Australia now. So the bad news is that human bias still overrides the machine accuracy. So long as there is human involvement, the biases of human is much harder to beat over the accuracy of the guided forecast. So basically, the system is learning and giving feedback to individuals that you shouldn't do this because there is only 30% chance of success, and still they override it because they really have the confidence that this is how they should be.
And there was one feature that I was very interested to use, and there was a reason for an override. So there was, whenever a planner did an override, he had the opportunity to provide a reason. And I thought, oh, that's a gold mine. Let's look at that information. What are they putting in there? And then I was disappointed. 99% of these values were empty. So the planners didn't provide a reason. So, and that's also something I discussed with the AI provider. Can you make that mandatory? Or maybe give a few reason codes, and does it have to do with promotions, with the weather, competitor actions, and then the planner needs to choose one of the reasons. But ultimate feedback was, no, that's too much effort. We can't implement that. Yes.
Shouldn't it, in theory, you showed us basically a snapshot, certain time periods,
Yes.
with diverging incidences, and success rates. But as in the background, the system is learning, is kind of basically the point that you made. Over time, this should all balance out. So the intervention of the human becomes much more random and less needed, because the system learns both from the intervention and from its own mistakes, which are not corrected, and gets better. And you initially made the example of the under ordering for Christmas 21, and then double compensating for it for Christmas 22, if I understood you correctly.
Correct.
That's, yeah.
So, and I agree, but the system needs data, and maybe not all the data is available in structured form. So, for example, if there, I don't know, if we are talking about Bully as a retailer and Codes is running a promotion and the system is not aware of this promotion, then somebody needs to put this into the system and adjust the numbers accordingly.
I mean, that's what you said, that the planner adds value when they're taking variables into account that the system doesn't take into account.
Exactly. Yeah.
Which the conclusion to that would be that the planner should not take any of the variables into account that the ITLS system is taking into account, because they will just add no value.
And maybe also, maybe the planner shouldn't correct the AI system at the moment of truth, but rather should spend his time on providing this information. Oh, the competitor is running a promotion into the system, and then the AI system is hopefully considering that correctly.
I think that's the sort of conclusion. I think we have to wrap it up here. Very interesting seminar, lots of interesting questions as well, great discussion. Thank you very much, Kai, for being small again. At least we do just one thing to do, and that is to invite you all for our next ITLS Leadership and Policy Seminar, which is happening tomorrow already. So we have a very tight schedule this month. And so tomorrow we welcome Kate Cainborn from the University of Leeds in the UK, and she will talk to us about the potential for persuasive messaging to increase active travel in transport and health apps. So thank you all for joining us today, and please do visit us again. Thank you.